This is one of my favorite experiments you can do at home. All you need is some milk, some food coloring, but you need the liquid kind, and some dish soap. You don't need the Q-tip, but it helps. It looks so cool, and the reason this works is because soap molecules have hydrophobic ends. That means that they don't like water, so they spread out over the surface of the milk. That's why this also works with water, because as the soap spreads out, it drags the food coloring with it, and you can use pepper if you don't have food coloring. This is how to see your breath when it's not cold outside, and no, it's not by vaping. Click your tongue on the roof of your mouth like a sound, but with your mouth closed and full of air. Then pressurize the air like you're trying to blow it out, but you're holding it in with your hand. Like a lot of pressure. Then slowly let it out. And putting it all together. When you click your tongue, you're making tiny water droplets in your mouth that can more easily evaporate. Then by pressurizing, you're actually turning that water into a gas. It becomes water vapor in your mouth. When the vapor hits the air, it condenses to form a cloud. It's not vaping, it's science. This is how to take an ordinary tea bag and turn it into a flaming comet. Don't do this near anything flammable. An adult supervision definitely required. Cut open a cheap tea bag, empty out the insides, and carefully stand it up on a fireproof surface. Light the end of the tea bag, and as the tea bag burns, it gets lighter and lighter until eventually the hot air rising from the fire lifts the tea bag right into the air, and then ash rains from the sky. How to pour out a candle without using water. Pour some baking soda in It's like that volcano we all did in middle school. Take some vinegar, pour that into the baking soda, but make sure the foam fills all the way to the top of the glass. Oh, too much. To cover the glass. You're gonna carefully move it over to the candle and then pour it out. It's like freaking Harry Potter. The baking soda and vinegar mix to make carbon dioxide, a gas that's more dense than air, so you can pour it like water. Pushes out the oxygen so the fire can't burn. Oh. This is a regular plastic spoon behind a special material. Same plastic in polarized sunglasses. This is what would happen if you crossed two pairs of polarized sunglasses at 90 degrees. But if you stuck another pair between at 45 degrees, yeah, you can see through it again. Light from most computer screens is polarized, and you can use that to see stresses in plastic. That's some science. 2 of these facts about space are true and 1 is a lie. Can you guess which one? Number 1, it takes tens to hundreds of thousands of years for light to get from the sun's core all the way to its surface before eventually escaping and traveling through space toward us. Number 2, space is not actually empty. While no sound can travel through space, there are particles that pop into and out of existence all the time in the vacuum of space. And number 3, if the sun were suddenly replaced with a black hole of the same mass, we would have about 15 minutes until the Earth was sucked into the black hole. And the lie is number 3. If the sun were suddenly replaced with a black hole of the same mass, we would just continue to orbit around it as if nothing happened. Although it would get very cold very fast and all life on Earth would eventually die. This is how to make a soda can explode open using just a Sharpie. And that popping sound, it's way louder in person. To do this trick, all you need is a warm soda can and a Sharpie. Hold the Sharpie pretty firmly and rub along the edge of the soda can tab. As the Sharpie presses into the aluminum over and over, it bends the thinnest part of the metal right there, weakening it in a process called fatigue. Until eventually the pressure inside the can makes it pop open and scare the crap out of me. I scream every single time. And pro tip, it works better with a warm can because the pressure's way higher. Some humans can see this unusual type of light, and here's how. Open up a computer screen to a completely blank white page, then tilt your head back and forth, just like this nerd. On most computer screens, you may start to see a yellow and blue pattern appear in the center of your vision. It's faint, but the pattern should look something like this. What you're seeing is actually called linearly polarized light, and it's the same type of light blocked by polarized sunglasses. You can do this too. If you cross 2 pairs of polarized sunglasses, you can completely block all the light. That's how you know if glasses are actually polarized. Plus, you can use polarized light to see structure like this in clear plastic. And the pattern on your computer screen, it's called Heidinger's brush. And it's caused by light-sensitive cells arranged circularly in your eye. Here's a space fact. Did you know that there's something between a planet and a star? It's called a brown dwarf. And it's too big to be a planet, but it doesn't fuse elements in its core like stars do. It's like the Liger of celestial bodies. Scientists still don't know how brown dwarfs form. Brown dwarfs have confused scientists for decades because they didn't know how to categorize them as planets or stars, which is crazy. How can you not know whether something is a planet or a star? But as you may recall, this confusion was the whole reason that Pluto got demoted as a planet. Goodbye, Pluto. This is how to touch the rubber of a balloon right to a flame without making it pop. Try it first with a regular balloon and a candle, and the heat will immediately make the balloon pop. but put a little bit of water into the balloon first before you blow it up. Then you can hold the balloon right on top of the candle flame. This works because water keeps the balloon cool, because it has what's called a high heat capacity. That means you need a lot of heat to raise the temperature of the water. In fact, as compared to mercury, you need 30 times as much heat to raise the temperature of the water. It's possible to light a candle without touching the lighter to the wick. What's happening is that you're lighting the smoke after you blow the candle out. The smoke actually contains a lot of wax vapor. It's a common misconception that a candle burns because the wick is burning, but it's actually the wax that gets hot, turns into a vapor, and then that burns. So you're lighting the wax vapor. This is how to make a ping pong ball float even at an angle. Take a straw, place the ping pong ball right above the straw opening, and blow a steady stream of air through the straw. When smooth air streams hit curved surfaces, they'll tend to follow around the surface, which is why you can also blow out a candle even with a cup in between you and the flame. I tried to do this with 2 ping pong balls, couldn't do it, but maybe you can. Here's a space fact. There's missing invisible matter in our galaxy, in fact, in most galaxies, and we call it dark matter. Super creative name. But we have crazy evidence for dark matter. When you see a star, the light from that star is coming at you in a straight line, right? Not necessarily. If there's a giant object like a galaxy between you and the star, then the light gets bent around the galaxy. Yeah, gravity can bend light. Albert Einstein predicted this with his theory of general relativity. It's almost as if there were a giant lens between you and the star. And we call this gravitational lensing. Super creative name. So depending on how much the light is bending, we can calculate how big the galaxy is because more mass, more gravitational pull. Then we look at the galaxy and calculate all the matter that we can see, and they don't add up. There's missing mass, evidence for dark matter. This is a strange property of water that happens on a hot pan. As you heat up a pan on the stove, water boils off faster and faster until it gets to a point where the water acts completely different. The water starts to bead up as if it's levitating. This is called the Leidenfrost effect, and it happens when the pan reaches above about 350 degrees Fahrenheit. If you add a little bit of food coloring to the water, you can see the effect even better. The Leidenfrost effect happens because the water on the bottom of the droplet boils off so fast, it creates this layer of vapor. The vapor acts like a cushion, almost allowing the water to levitate. That's some cool physics. This is a fun little experiment to follow up on the last one that I did. It's one of my favorite experiments you can do at home. Really cool. But there's more. When I first did this experiment, I noticed something weird. Did you see it? There's these little beads that roll across the surface of the milk. I thought they were antibubbles, which is this cool phenomenon that's a shell of air inside of water with a little water bubble inside of that. But no, they're just, globules is the best name I can find for them. They sometimes form in the sink when you're splashing around soapy water. This is just water, soap, and food coloring. They sometimes form in coffee if you stir it around with another surfactant besides soap, like creamer. And they form because the soap or other surfactant causes this boundary around the water to form, and it keeps the little globules protected and from joining back with the rest of the water. To make them, you can also just twist the Q-tip. This is what a ping pong ball can do to a soda can. You place a ping pong ball inside of a large PVC pipe. Then cover each end with Mylar and suck out all the air using a vacuum pump. Then I put in earplugs and I grab my safety goggles because when you puncture the Mylar, it's freaking loud because all the air rushes back in. And it pushes the ping pong ball out going over 500 miles an hour. The ping pong ball went straight through the soda can, which is why I stand far back and I don't put anything else near either end of the tube. The reason this all works is because air pressure is so strong and there's no air inside the tube to slow down the ping pong. This is what a ping pong ball going 500 miles an hour does to a banana. I'm back with my vacuum-powered ping pong ball cannon, but this time I'm gonna shoot it at a banana. I've got my earplugs in and my safety goggles on. Suck out the air. 3, 2, 1. The air rushes into the vacuum and pushes the ping pong ball out going 500 miles an hour. A ping pong ball going that fast has 68 joules of energy. That's still 6,000 times less than the energy stored in a banana. I got banana on my trigger thumb. Oh my god, there are pieces of banana everywhere. This is what a ping pong ball can do to an orange. I've got the ping pong cannon set up again with an orange ping pong ball and a real orange in front of it. Once we seal both ends, put on our safety goggles, and suck out the air, we can puncture the Mylar, which will allow the air to rush in and push the ping pong ball with incredible force. That's because there was nearly a vacuum inside of the tube. Although even at 99% of a true vacuum, there were still about 10 quintillion, which is 10 to the 19, molecules left in the pipe.
The whole peel. Where's the rest of the peel? Also, here's the ping pong ball.
This is how to make oobleck from household ingredients. You mix cornstarch and tonic water in the ratio 2:1. The tonic water has an ingredient called quinine, which will be important. The mixture will get pretty thick, but you can still pour it. The oobleck becomes solid when you move and stress it, but liquid when you stop because it's a non-Newtonian fluid. It gets pretty messy. Now grab a black light. The quinine in the oobleck glows because it fluoresces, which means it emits a lower energy visible light when it absorbs the high energy ultraviolet rays.